Hello everyone and welcome to Meet SRU Faculty. I'm Alyssa Cirincione, your host, and today our guest has had many accomplishments throughout his research and in his professional career as a computer science professor. Dr. Dailey is here today to talk with us about his experiences and achievements. So thank you for being here today, Dr. Dailey.
Well, thank you for having me.
You're welcome. It's a pleasure. So tell me what sparked your interest in computer science.
Well, I guess when I first started playing with computers, I discovered that I could use them to do things that I couldn't do by myself. I could solve mathematical problems, and I could figure out interesting research questions that would have taken hundreds of hours of my hand labor, but I could let the computer do all that work for me, and that was kind of fun. Yeah,
definitely.
So that was what got me started.
Yeah, very cool. So you've had a lot of experience working at different universities and colleges. What brought you here to Slippery Rock?
Well, they were starting up an IT program here, and I had started up an IT program in Massachusetts, and the program here looked like it was pretty solvent, a good university with harbored inside a computer science department, and a computer science department is a good safe home for a program like IT that was sort of adventurous and experimental in those days. Now it's more of a mainstream discipline, but in those days it was sort of the new kid on the block, and people weren't sure if the web would even stick around.
Right.
It did. And it probably will still be here for another century or two.
Definitely. It's just it expands every day.
Yeah.
You know.
Yeah, so it's an exciting field to do research in, and it's an exciting field to teach because one has to keep learning new things.
Right. Yeah, definitely. So you taught in Alaska. You taught at a university there as well as was it a community college in Alaska?
Yeah, the community college was the westernmost college in the world because it was so close to the international date line. And then I went to the big university in Fairbanks and taught for a couple of years there in the math department and in the psychology department.
Yeah, how was that experience working, in Alaska? That's
well,
kind of awesome to me.
Yeah, the temperatures were extreme, and the cultures were very, very different. Nome is a remote little town that's predominantly Eskimo, and very far from mainstream America. And in fact, you cannot drive to the rest of the continent from Nome. It's sort of an isolated little place. You have to fly if you're going to go anywhere. And but Fairbanks is sort of like America, just cold.
Right. Yeah, that's pretty cool though that you kind of lived in a little secluded area. I bet that was, very different, a little bit of a culture shock.
Absolutely. Well, and the temperature shock, having everything be so cold and so much snow and so isolated was definitely an unusual experience.
Yeah, definitely.
But it was fun. I'd not want to do it again, but I'm glad I did it.
Yeah, that's awesome though. So you've been to so many places all over the world for conferences and just for personal travel. Where is the most interesting place you've been to so far?
Well, probably the south of India in terms of being just entirely different than anything that I've experienced before. It was a very welcoming cultural experience. I was the first Westerner that many of the students at the university there had ever seen. And so people wanted my autograph, and people wanted to have their photos taken with me, and that was intriguing. I had never ever in my life been asked for an autograph, but I probably had 100 people at Chennai asking for my autograph.
Yeah,
so
that's
fun.
pretty cool though.
Yeah,
Were you there for a conference or just for personal travel?
No, I was invited to lecture. There was a student organization there called Kurukshetra. It's an annual festival of technology, and they had lots of dignitaries from the Indian government had come down to that part, and the fellow who invented Wi-Fi attended the conference, so it was a real interesting experience, and I got to eat really wonderful food, and the student organization took intensely good care of us, showing us around, and we got to go see Mamallapuram, which is an old Hindu religious site dating from 1200 AD. And,
oh, wow.
Got to see a lot of real interesting things in India.
Yeah, very cool. So do you have any upcoming conferences or travel plans?
Well, I'm currently in the midst of organizing a conference that will be in the Silicon Valley or in San Francisco in October.
Okay.
It's an annual conference that I've been involved in the organization of for several years. We've recently been in Tokyo, Germany, Paris. I put one together at Google headquarters a couple of years ago in California. Then I got Microsoft to host the conference in Boston 2 years ago.
Wow.
Then we were in Switzerland last year, and we'll be in the Silicon Valley again next year. And Adobe has been working real closely with us to help find a location. And we expect sponsorship from Adobe and Google and Microsoft.
Oh, cool. That's great. So what takes place at the conferences?
Well, these particular conferences are all on web graphics, and that's basically what my research has surrounded for the last few years. Innovative ways of using the web to display graphical images, and there are new standards being developed for 3D imagery and for 2D imagery, and the standard I've been working with is the 2D imagery, but the 2D imagery standard also includes specifications for animation and for multiple language support. And so it's a real interesting development, because now instead of having to rely on pre-built graphics, you can have graphics which are interactive. So an individual can look at the screen, touch parts of the screen, and then the graphic will change in accordance with what the user or visitor to your website does.
Yeah, that's awesome. That's pretty cool. So you're just kind of researching and developing new ways for that to come about?
Right.
Yeah. That's awesome.
Yeah.
So, all right. I'm going to be talking with Dr. Dailey about artificial gravity and navigating space on the web when we come back.
Hi, this is Neve Schulman, and you're watching WSRU.
Hi, I'm Albertosaurus. I'm 75 million years old.
I am Mike Madden.
My name's Steve Larson.
I'm Officer Robert Davis with the SRU Police Department.
Professional Studies.
Chairman of the Computer Science Department.
A student worker in the Computer Science Department, and you're watching WSRU TV.
SRU TV.
WSRU TV.
Watching WSRU TV.
You're watching WSRU TV.
Channel 27.
Welcome back, everyone, to Meet SRU Faculty. I'm Alyssa Cirincione, and I've been sitting here with Dr. David Dailey, a computer science professor. All right, so let's talk about your recent research, artificial gravity and navigating space on the web.
Okay, let's see if I can introduce the topic in a fairly non-technical way, since it's a fairly technical topic.
Okay.
Mathematics discovered, about a century ago, that there are spaces other than Euclid's standard space. When we learned geometry in high school, we learned the Euclidean axioms. And some mathematicians showed that there are other kinds of space that you can imagine that actually have some applicability. When you're looking at events inside atoms, for example, the nature of space may be slightly different than the space that we normally move around in. And so one can consider sort of generalizing or abstracting the essence of space and talking about what is a most general kind of space. And when one does that, you end up with something that in its bare bones looks a lot like the internet of all things, a set of locations that happen to be connected to one another. So you can consider a general theory of space as consisting of a series of nodes and connections between nodes.
Okay. And
it turns out that such spaces are about as general as you need to get in order for sort of a completely abstract theory of space. And so in these abstract spaces, there isn't necessarily directionality. We think of space as in sort of Cartesian sense, that we have perpendicular axes and that points can be talked about in the XY plane or in the XYZ space. But not all spaces have axes.
Okay.
And The way humans get around in ordinary space is we rely on things like landmarks or a sense of direction, or in some cases, knowing gravity. We know up from down because gravity tells us where we are, and gravity is very handy. So one wonders if in a really abstract space, one might be able to introduce sort of an artificial gravity that would allow people to have a sense of direction in a completely unpredictable kind of space like the internet. If you think of the internet as being a collection of websites or web pages connected to one another by hyperlinks, the structure of those hyperlinks forms a mathematical structure known as a graph. And the research question we've been posing is, to what extent can you introduce artificial directionality into a really abstract space like a graph? And if you succeed in flavoring a graph with gravity or with magnetism or with some combination of gravity and magnetism, could humans who are made aware of that artificial gravity use it to actually make their searches of that space more efficient? And so we're designing little tiny artificial spaces and actually using real human subjects in these experiments, and we're looking at the extent to which the presence or absence of gravitational cues can help people to navigate through structures like little mini internets.
Oh, wow.
And thus far our research has been pretty promising.
Yeah.
And it's interesting research to me because it's actually a cross-disciplinary kind of stuff. There's a mathematical side where we're actually proving theorems about spaces that can be flavored with gravity and those that can't. And then there's a computer science side where we're actually building algorithms to search through graphs to see whether or not gravity can exist or not. And then there's a psychological side where we're actually interested in how do people navigate in an abstract space. And so we're sort of making things like Dungeons and Dragons games where there are a set of rooms connected to one another and watching as people navigate through those rooms and seeing what sense of direction they can get and what sense of memory they can use to know how to get around when they go through it next time.
Right. Yeah, that's very cool. You know, just with, you know, how you're using real human, you know, sources for your research. You know, I think that do you think it would be more effective than not?
Well, it certainly brings it into an applied side.
Right.
Otherwise, it's just pure mathematical theory, and it's a fun mathematical theory. But it, you know, using our research thus far has indicated that sure enough, humans can use artificial gravity to successfully navigate.
Yeah.
And so that suggests that there may be practical value to what we're doing,
Right.
other than just furthering mathematical knowledge.
Yeah, you have to test your theories.
Right.
You know, to actually see if they work or not.
Exactly.
No, it makes sense. It does. Yeah. So you've had several books published, including one about scalable vector graphics. Tell me about your research with that.
Well, scalable vector graphics that I alluded to a little bit before commercial break is about the kind of graphics that are constructed out of vectors rather than pixels. Most of the graphics that you find on the internet or on computers in general are built out of little tiny dots called pixels or picture elements. And the problem with a bitmapped or pixel-based graphic is that you can't really stretch it without the pixels becoming big and noticeable.
Right.
And with scalable vector graphics, instead of describing something as a bunch of colored dots, you're describing it as a contour that has a formula and a fill pattern that has a color or a transition between multiple colors.
Okay.
And so the graphics are described more with a formula, and that makes the graphic much lighter weight and easier to ship. The file storage space is smaller associated with vector graphics typically than with bitmap graphics. But furthermore, it means that because the description is so lightweight that the recipient of the image, the visitor to your web page, can actually interact with it. And you can make dynamic charts, for example, so that people can get into a large, rich collection of data and sort of sift through it manually with the mouse or with a touch screen, so that you can pull up new visualizations of the data fairly instantly without having to make round trips to a computer located in California.
Right.
You're doing it on your own computer because it's all being done with this vector graphic stuff.
Yeah, very nice. So we talked about before, you know, how emojis, would they fall under scalable graphics, or would they fall under the navigating space on the web?
Well, there's more in the scalable vector graphics.
That's what I thought, yeah.
Right now, well, emoji are these characters that are funny little icons. They used to be called emoticons in English. In fact, people still use emoticons, like the happy face drawn with a colon followed by a hyphen followed by a parenthesis.
Right.
That's sort of one of the classic emoticons. And in Japan, the emoticons became very popular, and people started designing their own emoji. And there are now about 1,500 of these characters, and they've been accepted into the international vocabulary of writing systems called Unicode. So emoji have become official now.
Yeah.
And Apple discovered that you pretty much needed to have emoji in order to sell iPhones in Japan. And emoji have started to become popular in the United States among younger audiences as well. And right now, the emoji that are on most cell phones are not stretchable. They are bitmapped images, typically in GIF file format, and they don't scale well. If you wanted to draw a giant emoji on a screen, it would look terrible because of the way that it's been built for these small devices. And so I've got some students working on projects to actually encode the emoji script into scalable vector graphics so that they'll become a more scalable set of characters. And then, of course, looking to the future, one can ask questions about to what extent can we use characters like emoji to be meaningful in a cross-cultural setting. The meanings of emoji in Japanese culture and in American culture tend to be pretty similar.
Right.
And what other universal symbols might we find that could form the basis of some kind of an international language?
Yeah, definitely. So, and that's great that, you know, you're incorporating students within this research, because that gives them a lot of experience.
Well, yeah, I think it's been really wonderful. The students have gotten to sit across the table at dinner with the people who are designing the World Wide Web, and you know, at major international conferences. Slippery Rock students have had a rather unique and unusual opportunity to hobnob with some of the movers and shakers of what's actually going on at fundamental levels of the development of the modern web.
Yeah, definitely. That's great that, you know, like I said, they have that opportunity, and, you know, you can provide them with that opportunity as well.
Yeah. And they get to travel and present at international conferences, and generally I think they're having a ball with it.
Yeah, definitely. Sounds like it.
Yeah.
So, you know, with the books that you've published, what other topics have you covered?
Well, actually, there's just 2 books, and they're both on scalable vector graphics.
Okay.
One was published by the World Wide Web Consortium, and the other by Microsoft Press.
Okay. Wow. So, that's very cool. So, all right. But thank you so much for joining us.
Well, thank you.
It was a pleasure talking with you. All right. So that's everything we have for you this week. Tune in next time to see what faculty member will be joining me. I'd like to thank Dr. Dailey for being here today. Once again, I'm Alyssa Cirincione, and this has been Meet SRU Faculty. Have a great week.